All right, ready to dive deep today. We're tackling Rust and multi-threading, and we've got a fantastic resource for this.
Oh, yeah. What are we looking at?
A Medium article, fresh from December 2024. Rust and multi-threading, real-life applications and examples. It's by Unohu Ab1R, and let me tell you, they packed it with code examples.
Love that. Always better to see the concepts in action, not just the theory.
Absolutely. It's like, show me the code, right? So the article jumps right into how Rust is built for both safety and performance, which, when you think about multi-threading, can be a tough balance to strike.
Oh, for sure. You've got all these threads running around, potential for chaos, but that's where those key Rust features come in.
Okay, lay it on me. What are we talking about?
Ownership model, borrowing, channels, mutexes, the whole shebang, and of course, ARC. Can't forget ARC.
Whoa, a lot of jargon there. Let's break it down. Start with this ownership thing. What's that all about?
All right, so think of it this way. In most languages, when you've got multiple threads, they can kind of just access and mess with data however they please.
Recipe for disaster.
Pretty much.
Yeah.
Leads to all sorts of nasty bugs. But Rust is different. It's like, imagine a super strict librarian.
Okay, I'm intrigued. What's the librarian doing?
They're keeping meticulous track of who's borrowing what book, right? No one's scribbling in the margins. No one's ripping out pages.
So the data is the book, and the Rust compiler is our librarian, making sure everything stays in order.
Exactly. That's the ownership model. At any given time, only one thread has access to that piece of data. No data races, no concurrency bugs. Well, a lot less likely anyway.
Makes sense. But what about when threads DO need to, collaborate, like share data?
Ah, that's where borrowing comes in. Threads can borrow data, meaning they can read it, but they can't just change it without permission.
So like checking a book out from the library, you can read it, but you can't rewrite the ending.
Perfect analogy. But sometimes threads need to actually talk to each other, not just borrow.
Right. How do they do that without causing mayhem?
Rust gives us some cool tools. Channels, for example. Think of them like communication pipelines between threads.
So they're sending messages instead of trying to edit the same document at the same time.
Exactly. Avoiding those accidental overwrites and conflicts. Then we have mutexes. Imagine a whiteboard, but with a lock. Only one thread can hold the key at a time.
Okay, so only one thread can write on the whiteboard at a time. Makes sense. Prevents those jumbled messes.
You got it. Keeps the data consistent. But sometimes, threads DO need to modify shared data. That's where ARC swoops in.
ARC. Remind me what it stands for again.
Atonically reference counted. It's like a shared whiteboard that everyone can write on, but it's smart. It keeps track of who's using it. When everyone's done, it erases itself.
So it's like a self-managing whiteboard, making sure everyone gets a turn and nothing gets accidentally erased.
Exactly. Rust gives you all these mechanisms for controlling access to data. Multi-threaded programming, but way safer.
Okay, so we've got the safeguards in place. But how does this actually play out? In real-world scenarios, the article starts with web servers, which seem like prime candidates for multi-threading.
Oh, totally. Think about it. A web server, tons of requests coming in constantly from users, needs to process them quickly, efficiently. That's where multi-threading shines.
Like a team of chefs in a busy kitchen, each handling a different order.
Love it. And Rust is perfect for this because it's all about safety A&D performance. No one wants a server crashing because of data races or other bugs.
Right, reliability is key. But we also need speed, especially with all those requests coming in.
Exactly. And Rust delivers on both. It's low-level, efficient, but it's also got those ownership and borrowing rules to keep things from going haywire.
All right, let's get to the good stuff, the code. The article has this web server example, simulates multiple requests hitting a server, incrementing a counter. They use ARC and mutex to manage that counter safely across threads.
Ah, this is where you see those concepts in action. That counter. It's representing some shared resource on the server. ARC lets multiple threads access it, but the mutex is the gatekeeper.
Only lets one thread through at a time. To modify the counter?
You got it. So you've got all these threads representing user requests, all trying to increment that counter, but the mutex keeps them in line. No data corruption.
It's like a line of customers at a store, each waiting their turn to pay. The mutex is the cashier, making sure only one person's using the cash register at a time.
Perfect analogy. That's Rust's multi-threading in a nutshell. Controlled access, safety, reliability, even with multiple threads running around.
Okay, web service, check. What's next on our code tour?
Let's get a little more interactive. Game development. All right, let's switch gears a bit. Something a little less server-focused. How about we talk about data processing?
Data processing. Sounds a bit dry, but I'm sure you'll make it interesting. What kind of data processing are we talking about here?
The kind you probably use every day, even without realizing it. Think, browsing the web. There's a ton of data processing happening behind the scenes to make that experience so smooth.
Oh, yeah, you're right. Search engines, social media, all that data analysis and number crunching.
Exactly. And it's not just websites. Scientific research, financial modeling, you name it. These tasks often involve huge data sets. That's where parallel processing comes in.
Parallel processing. So like dividing up the work and having multiple threads tackle it at the same time.
You got it. Makes things way faster. And Rust has this awesome crate called Rayon. It basically supercharges your iterators.
Supercharge. Okay, now you've got my attention. How so?
Well, normally when you iterate over a collection of data, you're doing it one element at a time, right? Sequentially. But Rayon lets you parallelize those operations, like sum, map, filter, all those common data transformations.
So instead of going one by one, it's like splitting up the data and having multiple workers tackle it at the same time.
Precisely. It's like having a team of analysts working on a giant spreadsheet, each focusing on a specific section.
Makes sense. Much more efficient. So show me the code. How does this Rayon magic actually work?
The article has a great example where they use Rayon to process a vector of numbers in parallel. It's all about this function called pariter. Think of it as your parallel iterator.
Pariter.
Right.
Got it. So instead of processing each element one by one, it splits the vector into chunks.
Exactly. And then each chunk gets processed by a different thread. The example shows how to calculate the sum of all the elements in the vector, but in parallel. Way faster, especially for large data sets.
It's like taking a giant pizza and dividing it into slices so everyone can grab a piece and start eating at the same time. No waiting for one person to finish the whole thing.
That's a great way to put it. And this parallel processing power, it's not just useful for, summing numbers. Think about scientific simulations. They often involve huge EE amounts of data.
Oh yeah, like weather forecasting, climate modeling. Those are computationally intensive tasks.
Exactly. And multi-threading, it's crucial for speeding up those simulations. The article has an example where they use threads to calculate the average temperature from weather data, but they do it in parallel.
So instead of one meteorologist analyzing a giant weather map all alone, you've got a whole team working on different regions at the same time. Then they combine the results.
That's the idea. Break down a complex problem into smaller, parallel tasks. Rust makes that surprisingly easy to do. And it's safe, remember. We've got all those safeguards in place to prevent those nasty concurrency bugs.
Right, the ownership, the borrowing, the mutexes, all working behind the scenes to keep things running smoothly.
Okay, we've seen web servers, game development, now data processing, scientific simulations. Rust and multithreading seem pretty versatile.
They are. It's all about leveraging the power of modern hardware. Most computers these days have multiple cores. Might as well use them right.
Makes sense. Get the most bang for your buck, so to speak. But what really stands out to you from all these examples? What's the takeaway? For me, it's that balance. Rust manages to be both safe and performant. It's not an either situation. You can have both. It's like having a race car, right? But with a roll cage, seat belts, all the safety features, you can push it to the limit without worrying about, crashing and burning.
Love that analogy. So it's not just about speed, it's about speed with control. Safety net included.
Exactly. And that's what makes Rust so exciting for the future of software. We're relying more and more on multi-threaded applications. They're handling these increasingly complex tasks, and Rust just provides a way to build those applications without sacrificing safety or your sanity, honestly.
It's like having your cake and eating it too, right? Speed, efficiency, but without all the headaches of debugging those awful concurrency bugs.
Exactly. And I think this is just the beginning. More and more developers are going to embrace Rust. This whole approach to concurrency, I think we're going to see a wave of innovation, honestly. Just wait.
It's kind of mind-blowing to think about the possibilities. I mean, maybe we'll see operating systems written in Rust or real-time applications that just push the boundaries of what we thought was possible.
The potential is huge. And that's what's so compelling about Rust, It's not just a language, it's like a movement, this community of developers who are passionate about building better software, safer software.
More efficient software.
And that's something worth getting behind for sure. So if you're listening and you're a developer, maybe you've been hesitant to really dive into multi-threading. Give Rust a try. Seriously.
You might be surprised. It can actually be fun. Who knows? Maybe you'll build the next big thing, the app that changes everything.
Well said. I think that's a fantastic place to wrap things up. It's been a blast exploring the world of Rust and multi-threading. Hopefully our listeners learned a thing or two along the way.
Definitely. The big takeaway here, Rust offers a really unique,